All right, guys. So yesterday we talked about proportional relationships. Today, I mean, honestly, we're doing the same thing as yesterday. The only difference is now we're rational numbers, which is we're dealing with fractions. Okay. So with that said, we said yesterday that proportional relationships means that no matter what fraction that you use, they're going to be the same. So there's no need for us to go through and really do both set of numbers. We just need to do one. Now, I will tell you guys this. Let's make a couple of changes here. This was supposed to be a 1. I jacked this one up. And then this one down here was supposed to be a 9. Okay? Even then, even if you don't use it, you'll get the gist of this, but just so it stays proportional, because we want to, both the answers are the same. That's what it's supposed to say. So, either way, we're here. How many cups of water is required per ounce of sugar? All right, well, we know it's water, and then we also know it's sugar. Water came first, we put that one on top. Cool. Sugar second, put it on the bottom. Now, when we get to this point, you guys, let's make these fractions into decimals. It's just gonna make things easier. So we know that the 3 is gonna be in front no matter what. It's the decimal that we need, so let's do 1 divided by 5. 0.2, cool. Okay. And then on the bottom, we know that these are the set of numbers we chose. We're going to do 4 over 5, which is 0.8. Okay. Cool, so we divide 3.2 divided by 0.8. My answer is 4. Remember, we put a 1 underneath. So that way it stays a fraction. So that's why it's easier for us to read. So we got 4 cups of water for every 1 ounce of sugar. So we write that. 4 cups of water per 1 ounce of sugar. And then we're done.
Helen Monroy, please report to the front
Sorry.
office at this
Seems
moment.
like every video I'm going to do at lunch is going to have this in the
Monroy,
background. Sorry,
please
guys.
report to the front office at this moment.
All right, well, next one, same thing, you guys. How many cups of raisins? So it says proportional, so we don't need to do all of them. We just need to do one. But how many cups of raisins for every cup of peanuts? Okay. All right, well, raisins, let's just use the top one. So 4 divided by 5, 0.8. But there's a 2 in the front, so 2.8. Okay. And then over here is 8 divided by 3. Now, here's something that we're going to talk about here. I don't want to use all of those decimals, so let's just get this and keep this as, and we're going to round it, okay? So instead of 2 point all those 6s, we can just put 2.67, your guys' favorite number. Okay. Now, the key word that we have to have here, on top we said, hey, there's 4 cups of water per 1 ounce of sugar. This one, we're going to start off with there is about. Now, whenever we go through and we round, and we're not taking the full number, I want us to use the word about, okay? So whatever we get as our answer here, so if we do 2.8 divided by 2.67, this is about 1.04, okay? Well, actually, I should write this over here, I'm sorry. 1.04 over 1. So 1.04 cups of raisins per 1 cup of peanuts. Okay, there you go. So again, proportional means that no matter which set of numbers you choose, they're going to give me the same answer. So I just chose the top one. It's the first one I've seen. If you want to choose the bottom one, cool. You're going to get the same answer no matter what. But again, if I round numbers and if I don't use them all, we got to use the word about. Okay? All right, cool. Well, we've also got our next problem, which is going to be dealing with the graph. Okay. Now, please understand that this line was supposed to be all the way through. Sorry, I just put black there so you can see it. And when we deal with this next unit, you're going to see why. It's got to start at 0. Okay. But for now, don't worry about that. We do want to go through and make our little boxes, though, like the one above. There's two things we're talking about. This time, though, we're not really talking about sugar and water and things like that. This one says, hey, there's a proportional relationship between the hours worked. So let's put that here, hours. And money earned. Okay, so I got this. There's a relationship between these two. Now, what you guys want to do is you guys want to look to see where the dots are crossing on the corners. There's a dot here on the corner, a dot here. You can even use this one. There's a dot there. Do you see how we're looking at the grid? I don't want to choose some random number in the middle of nowhere, because what that does is it's going to make it really hard for us to read or estimate what that number is. Okay? So you guys decide, hey, my hours worked, my money earned for that one. So let's go put that in the chart. I'm only going to put 2 sets of numbers. There's no reason to put more. We're only going to use one anyways. So hours worked for the first one was 2.0. And money earned there was the $20. And then another one is our hours here and our money here. Okay, so 2.5 hours and $25 made. Once we get here, you guys, you have what you need, like above right there. Now you just got to read the question. So for our first question, it's saying, hey, find the unit rate for money earned for every hour. Okay. Pick a set of numbers, throw them in there, find out how much money you're making every hour. But money over hours is not the only thing that we're doing here. Okay, I could flip that. And instead of money over hours, I can have hours over money, which in this case, that's what it asks for. These are the only two that we can find. Okay? So find the unit rate for hours over every dollar earned or money. Choose a set of numbers again, plug them in. Now look, they're going to give you two different answers. This one right here, if I were to select it, money, let's say I chose the 20 that was right there and the 2.0. But this one was flipped, so is the numbers. So instead of 20 over 2.0, it'll flip like that. They're going to give you two different answers, so make sure that you guys go through and check to see what those two answers are. Then you write your unit rate out. One's money per hour, the other one's hours per dollar earned or per money. Okay? So whenever we're dealing with problems, if they don't give you a question, you got to try both. Or if they don't give you the unit rate, you got to do both. You got to do one, so hours worked over money. And then if I doesn't tell me what to do, you got to do the other one too. So instead of hours over money, you got to do money over hours. So we got to do both of them if it doesn't tell us. So for instance, the next one. The graph below shows a relationship. Okay? it doesn't tell me which route or what unit rate to do. So, hey, this one has a relationship between hours and miles. That's what it says right here. So I'm going to do this. So we got hours and miles. Let's pick some points. Now look, I don't want to pick these ones out of nowhere because that's ugly. You want to pick the ones that fall in the corner, like this one here. That's not a good one. If we keep going through, there's another good one, but this one's not a good one. For this one then, hey, 2.0 hours for every 3 miles. All right, cool. So, hey, hours, 2.0, miles, 3. And then we go back over here, and hey, there's another one. So this one's 4.0 miles, 4.0 hours and 6 miles. Now, there's two answers here. It says select all statements. There's more than one. And the reason why is because what you guys usually hear is miles per hour, right? But that's not the only unit rate. Even though we don't use the other one, there's multiple. So miles per hour and hours per mile. Now, if we were to throw this in, let's see, miles, let's use a 3 here and a 2.0 here. I'm actually going to maneuver this down over here. My bad. So if we divide that, 3.0 divided by, it's 3 divided by 2.0, so 1.5 over 1. And this tells me 1.5 miles for every 1 hour. Well, which one says 1.5 miles every 1 hour? But again, that's not the only thing. We've also got hours over miles. So if I go over there, let's use the other one. Let's do 4.0 hours over 6 miles. Okay, well, 4.0 divided by 6. So about that many hours every 1 mile. So about 0.67 hours for every 1 mile. Okay, well, let's see which one says that. Well, I mean, the closest numbers to it are B and C. So obviously I know this one's wrong. I already chose the other one. Now, which one says about 0.67 hours for every 1 mile? Because the other one says about 0.6 miles, but that's not on the same side. Okay. Cool. Now, last thing, for these ones right here, you guys just need to make sure that you guys put some dots on there. I don't want to choose these random dots. You go down the way. Where's that laser thing? Let me do this different color. You go down the way, and hey, look, that crosses perfectly on the grid. That's a good one to use. And then you can continue going down until you find another spot where it crosses the corner of the grid. This tells you here, the grid in the background, the black grid, that tells you where it'll hit some numbers nicely. So if I do this, this one's saying between oranges and apples. So I'm going to put an orange and an apple, A for apple. Well, this one for oranges is, looks like we're counting by ones, right? So 3 oranges for every 2 apples. Okay, so 3 oranges for every 2 apples. which if I go over here, after 5 is 6. And then we have to assume that it's counting by ones, right? So this one's 6 oranges to 4 apples. And then remember, there's 2 unit rates that you need to create on your own to get me my answers on the bottom. All right, see you guys.